Hi, this is Algebra 2, Lesson 25. We're going to talk about monomial factoring, cancellation, and parallel lines. We're starting on page 116. Factor comes from the Latin word for maker or doer. If we multiply 3 times 2, we get 6. We say that 3 and 2 are factors of 6 because we can make 6 by multiplying those two numbers. If we can make an expression by multiplying 2 or more other expressions, we say that each of the expressions that we multiplied are factors of the final expression. Or, if we have an expression, in this case 6, and we can divide it, because of course division is the opposite of multiplication, then we would say that 3 and 2 are factors of 6. We can look at it this way because we can multiply 3 times 2 equals 6, or because we can take 6 divided by 2 equals 3. Okay? Here's a more complicated expression. If we multiply 4x times the quantity ax plus y, we're going to get 4ax squared equals 4xy. And therefore, these two terms are factors of this sum, or this expression. When we write a sum as the product of its factors, we say we're factoring. Okay? So most of the time we're going to see the sum and we are going to find the factors. We find the factors by finding the greatest common factor of both terms and then dividing it by the terms, which leaves us with our original factors. So in this case, if we were just starting here, we would look at both of these terms and see that they both have a 4 and they both have an x. So we would divide the 4x from both of the terms. We have the 4x out front, and that leaves us with an a and another x here, ax. Plus, we take out the 4x and it leaves us with a y. So we have factored this quantity. Okay, so let's try this one. We're going to factor 4x squared p squared k minus 6k squared p to the 4th y. So we're going to find the greatest common factor of all of the terms. Okay, we've got a 4 and a 6, so the greatest common factor of 4 and 6 is 2. We have an x squared here and just one x over here, so we can pull out 1x. We have p squared and p to the 4th, so we can pull out 2 p's, p squared. And we've got k here and k squared here, so we can pull out 1k. Right? We're going to pull that out. That means we're going to divide this term from each of these terms. 4 divided by 2 is 2. X squared divided by x is x. P squared divided by p squared is 1. And k divided by k is 1. So we don't need to write those down. Minus 6 divided by 2 is 3. K squared divided by k leaves us with 1k. P to the 4th divided by p squared leaves us with a p squared. And x divided by x is 1. So that is how you factor this term, and that's what it leaves you with. Okay, let's try another one. We're going to factor 4x squared y minus 2xy plus 10xy squared. Okay, so from the coefficients we have 4, 2, and 10. Our greatest common factor is going to be a 2. For our x's, we have x squared, x, and x. So our greatest common factor is just an x. For our y's, we have y, y, and y squared. So we're going to pull out a y from each term. Okay, 4 divided by 2 is 2. X squared divided by x is x. Y divided by y is 1. 2 divided by 2 is 1. X divided by x is 1. Y divided by y is 1. We're just going to write a 1 there. plus 10 divided by 2 is 5. X divided by x is 1. Y squared divided by y is y. So we end up with 2x minus 1 plus 5y. And remember that this term did not turn into a 0. We can't leave it off entirely. We just were waiting because if the coefficient had turned out to be 1, but there had been some variables after it, we wouldn't have had to write the 1. But we do need a placeholder here because there is a 1 here. Okay? Cancellation. We call multiplication and division inverse operations because they undo each other. For example, if we start with 7 and we multiply it by 2, and then we divide that product by 2 again, these 2's cancel and we're left with 7. Anytime there is a common factor in the numerator and denominator, we can cancel the common factors. So here we have 4.062 times 3.0176 divided by 4.062. So these two are common factors and we can divide them, and that leaves us with 3.0176. Okay, here's another one. We have 4 times the quantity x plus 2, all divided by 4. These 4's cancel, and we're left with x plus 2. Here's another one. We have x plus 4 over 4. This time we cannot divide out of 4 because there is no 4 in the x term. We can't say this is now x plus 1. We can't divide this 4 from this 4 because this is the whole sum and there is no 4 in front of the x. So this just stays the way it is. This just equals x plus 4 over 4, and we can't do any more simplification. Now we have a 4 in front of the x and here at the end. So now we could actually factor out a 4 from the top. If we factored a 4 out of both of these terms, we get x plus 1 over 4, and now we can cancel the 4. Okay, do you see the difference? We have a 4 in both terms in the numerator, and therefore we can factor out a 4. We can cancel a 4 from both terms. Here there was no 4 in front of the x, so we cannot factor it out here. Cancel if possible. For a, we have 6x cubed plus x squared all over x squared. From this denominator, we can pull out some x's. There are x's in both terms, so we can factor out x squared from on top. That will leave us with x squared. We'll still have a 6 here, and we'll have another x plus 1. All over x squared. And now we can cancel the x squares, which leaves us with 6x plus 1. Okay? Okay, over here we have 6a squared plus x squared all over x squared. We can't factor out an x squared from the top anymore because this term doesn't have an x, it has a's. It has a squared. We don't have an a squared on the bottom. There is nothing we can do to this one to simplify it any farther. It is left the way it is. Okay? Let's talk about parallel lines. We've talked about similar triangles like these. In both cases, these are two similar triangles because their angles are equal. They're shared. This one is sharing the A. This angle B and C are equal, and these two angles are equal. So the corresponding angles are equal, so these are similar triangles. And this one, the A's are opposite angles, so we know they're equal. We're told that C is equal to B, despite my drawing. And if these two angles equal these two angles, that means that this one must also be equal to this one. Okay, so these are similar triangles. Parallel lines also tell us that triangles are similar. So if we have this triangle and it doesn't tell us that the angles are equal, other than A, because we know that this little triangle is sharing angle A with the big triangle. So we know that A is the same, but it didn't tell us if C or B are the same. What it did tell us is that this line is parallel to this line. If two triangles share their vertex and their bases are parallel, then we can say that these angles are similar. And that makes sense. If we extend this and pretend it's a transversal, then this transversal is cutting these parallel lines at the same slope, which means that this angle is going to be equal to this angle. Likewise, if we extend this and say it's a transversal, then this transversal is going across these two parallel lines at the same slope, which means that this angle has to equal this angle. Okay? The same thing over here. Instead of having a triangle, we have two transversals that are meeting at this spot A. They're crossing two parallel lines, and therefore this angle has to be equal to this angle, and this angle has to be equal to this angle. Okay? Here's a fancier one. Here are two parallel lines. They're being cut by two transversals which cross each other. Because they're crossing each other, these two are opposite angles and therefore must be equal. And we know that the corresponding angles are going to be equal. So this line is transversing this line here and this line here. So this angle has to equal this angle. Oops, too high. And this one has to equal this one. Watch which ones are your corresponding angles. Okay? Now we have this fancy one. We have two parallel lines. We know that these two angles have to be equal because they're opposite. We have this transversal is crossing this parallel line and this parallel line. So that this angle needs to equal this angle, and this angle needs to equal this angle. It's always a little tricky to find those corresponding angles. Okay? So these angles are similar. So whenever a figure has parallel lines, you should be able to find the equal angles. Okay? You're going to do these just like you've done all the other ones. Find the corresponding angles depending on the parallel lines and then the lines that cross them. Okay, that's it for this lesson. Try your practice problems. Let me know if you have any questions. Thanks.